In this video, we're going to go over how to integrate using long division, how we can recognize it, and how we can use it. So in this problem, we're given a fraction and we're asked to integrate it. So I'm actually just going to take a look at these leading terms. And leading terms, when I say that, I mean we're looking at these powers. So this is actually going to be a 1. If we ever have an integral of a fraction, if the leading term's power is greater than or equal to the leading term's power in the denominator, right? So we're comparing these two numbers, then we know that we can use long division. So the way you set that up is like any long division problem that you did in elementary school. So that's going to be 3x cubed minus 5x squared plus 10x minus 3 divided by 3x plus 1. And this isn't the case for this problem, but if we ever have a case where we don't have a term, if any of these terms are missing, then we still need to put in a placeholder like that so we can go through with the problem. And that applies with this number over here. But again, this doesn't apply for our situation. So to actually go through with the problem, we need to just take a look at these leading terms. Ignore everything else for now. We're just going to deal with these two terms. So we need to ask ourselves, what do we multiply 3x by in order to get 3x cubed? Well, we know that if we multiply x squared, we'll get from 3x to 3x cubed. So I'm going to write our x squared just right up here. And it doesn't really matter where you put it. I just like to put it above our other x squared term just for neatness. So we have our x squared. We're going to distribute this term by this 3x plus 1. So if we do that, x squared times 3x is going to be 3x cubed. Then x squared times 1 is just going to be plus x squared. From here, I'm going to subtract everything from what we have up here. But the way I like to do this is just to flip the terms, the signs on the terms, and then add them together. So this is going to cancel out. Negative 5x squared minus x squared is going to be negative 6x squared. Okay, so now that we have that, we need to bring this term down. So I'm going to write an arrow plus 10x. And we can do the same thing for these leading terms. So what can I multiply 3x by in order to get negative 6x squared? That's going to be negative 2x, right? So I'm going to write our negative 2x up here, then multiply this through these two terms. So negative 2x times 3x is going to be negative 6x squared. Negative 2x times 1 is just going to be negative 2x. We once again subtract. So I'm going to flip the terms signs. Then these cancel out. Then 10x plus 2x is 12x. And then for our final term, again, we got to bring it down. So 12x minus 3. Then again, we compare the leading terms. So if we multiply 3x by 4, we'll get to 12x. So I'm going to write our plus 4 up here. Then again, we distribute the 4 to our 3x plus 1. So that's going to be 12x plus 4. Then we got to subtract. So flip the signs. Then these cancel out. And we're left with negative 7. So here's our remainder, and this is actually going to be the numerator for our remainder. So I'm going to add another plus over here, then write our remainder that we have, so negative 7, and then put that over our 3x plus 1. And this is going to be the term for our remainder. So what I've done is essentially just divided out this term by this polynomial. So now we have something that we can actually integrate. So I'm going to scroll down and I'm just going to rewrite this in a different color. So for these, I can just work term by term. We know that the integral of x squared is going to be 1/3 x cubed. Integral of 2x is x squared, so minus x squared. Integral of 4 with respect to x is just going to be plus 4x. And then this term, I'm going to write this over here just for clarity. And I'm actually just going to skip a step and move this 7 outside of the integral. So 7, 1 over 3x plus 1 dx. So we have a 1 over u. I know this is going to be a natural log problem. Our u prime is going to be a 3, so we need to multiply a 3. And since we're multiplying by 3, we also need to cancel it out with the 1/3. So for this term, we're left with minus 7/3 natural log 3x plus 1. And don't forget our plus c. Okay, so just a quick recap on what we did. We had this problem up here, and we checked the leading terms. And we said that the power up here was either greater than or equal to this power down here. So what we did was we actually divided this polynomial by this polynomial down here. And then we got that when we divided, this was our answer. And then we just integrated these terms like so. And then this is our answer that we got. Hopefully this helped.